So we just did a little bit of discovering about inequalities, and we're going to continue on with that a little bit. We are going to start with solving one-step inequalities, and the goal for today is just to be able to solve with one step and knowing the rules that are involved with inequalities and kind of what an inequality does, how we graph it, and things like that. So that way when we come to class next, we can dive right into adding two steps and multi-steps to solving with inequalities. So we just went over this, but just so you know that an inequality is a mathematical sentence that uses an inequality symbol to compare values. So that's the big thing here that we need to know, is that we are comparing values. It's not equal. So it's either less than, greater than, less than or equal to, or greater than or equal to. So if this is something that you'd like to write down at this point, go ahead and pause the video, copy this down, and then hit play to move on to our first couple examples. So a lot of what we're going to do in this unit with inequalities is very similar to our unit that we just finished up with equations. So we're starting off with, is it a solution? So now we just talked about that this is a mathematical sentence, just like an equation is. But an equation says that the two sides, the left and the right, are equal. Here we are using an inequality to compare. So here we have the less than symbol. And we're saying that we're looking for numbers that are less than 20. There is an infinite amount of numbers that are less than 20. So there's more than one solution. But there's also a ton of things that are not solutions. So just like when we were checking to see if it was a solution to an equation, well, we're going to plug in the value and see, is the statement true or not? Now, it's not just going to be one answer. That's why we have to make sure that we check every single one, because we can have more than one solution, because there's a ton of numbers that are less than 20. But there's also a ton of numbers that are greater than 20 that would not satisfy this inequality. So let's go ahead and try the first one. So we have 2x plus 4 is less than 20. Well, we're going to take 2 and we're going to plug it in for x. So we have 2 times 2 plus 4. Is that less than 20? That's what we want to know. So 2 times 2 is 4. And 4 plus 4 is 8. So we have 8 is less than 20. So we want to look at that final statement and say, is this true or not? Is 8 less than 20? Yeah, it is. So that means 2 is a solution. Now, that doesn't automatically mean 10's not. 10 could still be a solution because we have an infinite number. But we also have an infinite number that are not, so we have to check it. So let's go ahead and check 10 as well. So if we plug in 10, we have 2 times 10 plus 4. We want to know, is that less than 20? So we want to go ahead and simplify order of operations, do multiplication first. 2 times 10 is 20. Then we add, we have 20 plus 4 to get 24 is less than 20. So we look at this final statement and say, is it true or not? Is 24 less than 20? No, it's not. So that means that this is not a solution because it does not make the inequality true. So just like with equations, we plug in the value, we simplify, and then that last statement we want to say, is it true or not? If it's true, the comparison is true, it is a solution. If the comparison is not true, then it's not a solution. So now we're going to look at the graphing portion of an inequality that represents that comparison. So we looked at this on our activity. So it says use a number line to graph each inequality. So the biggest thing is right down here. So if we want to go ahead and write this down in our notes, that'd probably be a great idea. And we're going to consistently use this throughout the unit. So if we want to graph the inequality, it says m is less than 1. So when I'm asking you to graph something, I need two numbers on your number line. One number that always has to be there is 0. That's kind of our standard value that we can say, okay, to the right is positive, to the left is negative. And then we need the actual value that we are comparing. So 1. So I'm going to put 1 right over here. And then I need to decide, okay, at 1, is 1 included or not? Is it equal to or not? Well, there's no line underneath, so it's not equal to. So that means it doesn't include 1, so I need an open circle. Then from here it says m is less than 1. So I want to shade all the values that are less than 1. Well, 0 is less than 1. -1 is less than 1. -10 is less than 1. But if we go to the right, 2 is not, 3 is not. So that means we're going to shade to the left. And it's going to continue on forever. So we're going to go ahead and add an arrow there. So go ahead and try this next one. So pause the video, write n is greater than 5, and go ahead and graph that. Once you're done, play the video to go ahead and check your answer. All right, so n is greater than or equal to 5. So I need to identify 0. And then 5 is going to be over here somewhere on the right side. Now it's greater than or equal to, so it can include 5. It can equal 5. So I'm going to go ahead and fill that in, meaning that it can equal 5. 5 is a solution. I want all the values greater than 5 or equal to. So the shading means equal to. Greater than is going to be to the right. And it's everything to the right, so I'm going to put an arrow to say that this is going to continue on. So we're going to continue to do this with each of our examples. So now that we've got some of the basics about inequalities down, we're going to go ahead and begin solving one-step inequalities. So some rules to remember. We are going to solve just like we would with an equation, what we just finished up, using inverse operations to get the variable by itself. Then we're going to use that skill that we just learned about graphing to go ahead and graph our solutions visually on a number line. So the biggest thing to remember is that when you multiply or divide both sides by a positive number, the inequality stays the same. But when you divide by a negative on both sides or multiply by a negative on both sides, you have to flip the inequality sign. So that would mean if you had greater than and you divided by a negative on both sides, you would have to flip it to greater than. Less than goes to greater than goes to less than. And if it was greater than or equal to, it would change to less than or equal to. So if you want to go ahead and copy this down in your notes, pause the video, finish copying, and then hit play to move on to some examples. So our first example, this is solve and graph. So here we can see we have x minus 3 is greater than 8. We are going to solve just like an equation, but we're going to go ahead and keep the inequality sign. So our goal is still to get the variable by itself. So I have a minus 3. So the opposite, the inverse, would be to add 3. And if I add to one side, negative 3 plus 3 cancels, gives us 0. I have to do it to the other side to keep it even. So then I bring down the x, bring down this inequality symbol, and then I have 8 plus 3 is going to give me 11. So I have x is greater than or equal to 11 is my answer, and I want to go ahead and graph that. So I have 0, 11 is going to be over this way. I have it's greater than, not equal to, so it's just going to be an open circle because it doesn't include 11. And greater than is all the values to the right, 12, 13, 14, 15. So I'm going to shade this way and add an arrow to show that it continues infinitely to the right. All right, so now let's look at the next one. We have 4 is greater than or equal to c plus 2. So our goal is to get c by itself. So we have to get rid of that plus 2. Well, to get rid of a plus 2, we need to subtract 2 because 2 minus 2 gives us 0 and it's going to cancel. If we do it to one side, we have to do it to the other side. So we get 4 minus 2 is 2, which is greater than or equal to c. So this is our solution. But if we look at this, this is kind of difficult to read. Like that is the correct inequality, but x is greater than 11. That makes sense to us. 2 is greater than or equal to c. That may not make as much sense to us. We could absolutely graph from that, but what I would suggest is always changing it so that the variable's on the left side. So I would take c and 2 and I would flip them. And if I flip c and 2, I also have to flip the inequality. So it's going to go from greater than or equal to less than or equal to. So these two are saying the exact same thing, but I would suggest flipping it because this is way easier to graph. So if I flip the number and the variable, I also have to flip the inequality sign. So now I could go ahead and graph this. I have 0 and I have 2. Well, it's equal to, so that means it includes 2, so I need to have a closed dot. But this is less than. So if I go to the right, those numbers are all getting bigger. I want the numbers that are getting smaller, so I'm going to shade to the left. Less than is going to be to the left, L and L. All right, our last examples here are, we're now getting into that multiplication and division. So this is where we have to be careful, where we had that rule that we wrote down about flipping the sign. So let's take a look. Number 3, we have n divided by 3 is less than -1. Okay, we're trying to get n by itself. We have divided by 3. So to get rid of divided by 3 would be, let's multiply by 3. We do it to one side, we got to do it to the other. So this is going to cancel, and I'm left with n is less than -3. And that is the answer. Now, we did not flip the sign because we multiplied by a positive 3 on both sides. Positive, positive, inequality sign stays the same. So if I go ahead and graph this, just to keep getting the practice, I have 0. -3 is going to be to the left. Less than is going to be an open because it does not include -3. And then it's less than, so less is going to go to the left. Don't forget that arrow. All right, now we got number 4. We have -5a is greater than or equal to 20. So we want to get a by itself. These two things are being multiplied. The opposite of multiplication is division. So I'm going to divide by -5 on both sides. Oh, well, what did I just say? I said I'm going to divide by -5 on both sides. So since I divided by a negative, this is when I flip the sign. So my -5's cancel and I'm left with a. 20 divided by -5 is -4. But I need to go ahead and flip the sign. So instead of greater than or equal to, it becomes less than or equal to. I flip the sign when I divide or multiply by a negative on both sides. Here on the left, it was a positive. Don't do anything. When it's a negative, gotta flip the sign. So to graph this, I have 0 and I have -4. And this is going to be a closed circle because it includes -4. And it's less than or equal to, so we're going to shade to the left. So the reason that we flip the sign is because on the left side, we went from a negative value and then changed it on the right side from positive to negative. So if we go from positive to negative, we're becoming less, so we have to go ahead and flip that sign. All right, so let's go ahead and give you guys just a couple practice problems. So here we have 4 practice problems. So I would like you to go ahead, pause the video, copy down all 4 of these problems, solve and graph. And then once you've attempted them all, hit play. So then you can go ahead and check your answers and see how you did. And if you didn't get them correct, go ahead and fix those so that you have the correct answers in your notes. All right, so go ahead and check your answers. So for number 1, you should have gotten x is greater than -6 because you multiplied by a negative on both sides, so you have to flip the sign. You got an open circle shaded to the right. For number 2, we want to subtract 6 on both sides, so we get x is greater than -4. Adding and subtracting, we don't do anything to the sign ever. That's only when we multiply or divide by a negative. So we have an open circle shaded to the right. Number 3, we did divide by a negative on both sides, so we flip the sign to get m is less than 2, positive 2. And so we have an open circle shaded to the left. And then last but not least, we add 7 to both sides. So we get 19 is less than or equal to x. Well, that's a little bit tricky to graph, so I'm going to go ahead and flip that. So I did. I switched the x and the 19. And when I flip the variable and the number, I also have to flip the sign. It went from less than or equal to greater than or equal to. So now I can go ahead and graph this, which is a closed dot shaded to the right. So now, hopefully you have a better understanding of how to solve with one-step inequalities. May have been something that you've seen before, but now when we come to class next, we can go ahead and start practicing right away with adding 2 steps and multi-steps because we know the basic rules, and we also have a solid foundation of solving from when we worked with equations.